Alrighty, folks, we're going to go ahead and kick it off, okay? So we're going to go ahead and kick off. It's going to be module 75202-03, and you'll see it's going to be on page 2-1 in that book, okay? And you'll see it says Hazard Recognition, Evaluation, and Control. This is something I want you to remember. This is really recognition, evaluation, and control, right? It's really more of an industrial hygiene term, but it's used a lot in safety. We're using it a lot around here. So let me give you an example, right? This is the biggest thing, is remember, REC, right? Recognize, evaluate, control. So let me put it in perspective for you a little bit. Let's use a scaffold, for example, right? And let me do this. Let me pull up for you. If anybody's never done this before, this is a really, really easy thing you can do. Scary scaffolds. Scary scaffolding is fine. Okay. You come here and whatever, it'll pull up all kinds of crazy stuff for you, right? So let's just use, for an example, let's use this, right? Okay. This particular photo here, as you see, the biggest thing is, and this is what I tell everybody, right? When we do an inspection, sorry about that. I don't know what happened. Hang on 1 second. Let's see. Let me pick a different one. Let's just do scaffolding. Okay, let's just do this one, right? Let's just pick one like something like this, and let me give you an example. Okay, can you see that photo all right, folks? Is that clear enough? It's a heavily weighted picture, so okay, good. Okay, so let's use an example, right? As you can tell, all of these, right? You see how well the scaffold's put together, right? It's a lot of all the scaffold boards are all put together nice and tight. Okay, you see you got your mid rails, your top rails, right? Whatever the case may be, right? Okay, this is what I tell people. This is how I like to use it in safety. REC, we have to be able to recognize the hazard. Okay. Now, should the employee be on a guardrail? No, right? But as long as the employee is tied off, because since they're assembling and disassembling that guardrail, there's going to be some climbing that these builders are going to have to do, right? Where they're assembling or disassembling this scaffold. So anyhow, an item like this, basically what I'll do is I'll go back and say, okay, I got to recognize the hazard, right? What's the hazard? The employee standing on the guardrail, right? Okay, so then what I'm going to do, I need to evaluate, right? But what am I going to evaluate? Well, how about we evaluate what the hazard is, right? What significant hazard is, what the negative impact can be, which we know the greatest risk is fall. Not only that, but how much torque and tension is that employee also putting on that top rail, okay? But in addition to that, we got to evaluate the OSHA standards, the ANSI standards, which we often don't have access to, and the manufacturer specs, if we have them, okay? So we take all that, so we recognize the hazard, right, or hazards. We evaluate what the hazards are and what the standards are and what potential corrective actions we have, right? And ultimately, we control the hazard. Ultimately, we implement whatever safety practices we have to implement, right? And when I'm talking about implementing, what are we going to implement with? Our hierarchy of controls. We're going to go back to that whole engineering, administrating, and PPE controls, and then we're going to go ahead and control that hazard as much as possible. You see where I'm going with that? And that's with every hazard we have, y'all. We have a hazardous chemical, right? Let me give you an example. We got employees that are dealing with hazardous chemical. Let's say they're dealing with an area that might have benzene in it, right, or toluene. Well, we're going to do the same thing. We got to recognize the hazard at the end, right? The hazardous environment they're in. And then we have to evaluate the hazardous conditions they're in, but we also have to evaluate the OSHA standards, the NIOSH standards, okay, American Petroleum Institute, right, whatever their standards are, and also see what's available to us as far as being able to control the hazard. And ultimately, we're going to implement the controls. Ultimately, we're going to engineer it first, right? Hey, can we remove the hazardous chemical? Can we substitute it for something else, right? Can we use ventilation to ventilate away from the employees? Okay, there's our engineering controls, right? Second of all, administrative controls. What are we talking about? Hey, now can we position the employees where they're down, where they're upwind, right, or crosswind of that hazardous chemical? In addition to that, we need to fit test them. Authorized personnel only. Only employees that have been trained around to work around that hazard, okay, or for that type of practice are allowed to work in that area. And then ultimately, in the end, we're going to apply every control that we have. Everything we just evaluated, right? Now we're going to apply those controls, right? Engineering, administrative, and then ultimately what's left? Respiratory protection, right? Half face, full face, right? Different cartridges, forced air purifying, just depending on what's going to be necessary. Okay. So I mean, I'll always fall back on that REC. Okay. All right. So let's go ahead and talk a little bit, and then let's talk about a little bit of 2.1. You'll see that they're talking about accident incident types, right, and energy sources. So accident incident types, and then we're talking about energy sources, and the considered potentially hazardous, right, or potentially hazardous indicators. Best approach is determining if the situation, right, or the equipment is potentially hazardous. And then we got to ask ourselves some questions. What are we going to ask ourselves? Hey, how can this situation or equipment, how can it harm us, right? What type of energy sources are present? We'll talk about energy sources in just a moment. Okay, that can cause an accident, right, or an incident. Also, what's the magnitude of the energy? So if it's electricity, how many amps, right? How many volts? If the energy is a chemical agent, how strong or how potent is that chemical? Okay, so just different ways that we can quantify that hazard. Also, what can go wrong to release that energy? Is it something on the stored energy like springs or struts or shocks, right? Is it something that's locked out or tagged out? Is it like a dump truck bed that may be caught in the up position, or a press that may be caught in the up position and gravity may bring it back down, right? Push it back down. Also, how can the energy be eliminated, or how can we control it? Will it be exposed to any hazardous materials? Are there going to be any hazardous materials or chemicals? Am I going to be exposed to lead, right? Hexchrome, silica, asbestos. So we start going through the whole list of hazardous chemicals: toluene, xylene, benzene. In addition to that, before you carefully answer these questions, right, we need to know the different types of accidents that can happen from energy sources. So what are we talking about, right? Well, there's some different types of accidents that can cause injuries, right? What are we talking about? Falls on the same elevation, or falls from other elevations, from elevated work areas, being caught in, under, between, coming in contact with acid, electricity, heat, cold surfaces, radiation, pressurized liquids, gases, toxic substances, being struck by a falling object, being cut by tools or equipment, exposure to high noise levels, possibly repetitive motion or excessive vibration also. So when equipment's the cause of the accident, it's usually because there was an uncontrolled release of energy. So what are we talking about? Lockout, tagout failure, right? Usually, if equipment's involved, usually what happens is one or two things: either we failed to properly lock out, tag out, or it was re-energized and employees weren't advised; they moved out of the way before somebody was injured. Okay, so different types of energy that we have to lock out, tag out, right? Mechanical energy, anything in movement. Could be auger bits, could be blades, could be pistons, anything that could be in movement. Also pneumatic, basically air powered, hydraulic powered, electrical, chemical, thermal, hot or cold, either way. Radioactive, it could be gravitational, where, like I said, a dump truck bed or the top of a press that's stuck in the up position, maybe they got jammed. And then any type of stored energy being like capacitors. Anybody who's familiar with struts, like on a vehicle? So, okay, so let me show you, right? Okay, so most of you are, so let me go to them, right? Okay, so for anybody who's not familiar, right? Let me take you in and show you like a strut. Here we go. Say a strut assembly, right? Okay, but I want to show you something. I want to show you the tool. Okay, so what happens is a lot of times people, let's say mechanic shops back in the day before they actually came out with strut tools. Let me bring you to the tool. Okay. So here you go. This is what I'm talking about right here, okay? Like these strut tools right here that you see. Basically what they do is they bite on the bottom and they bite on the top, and they're pulling that spring together so that you can put that strut assembly back in its place, okay? It's strut, for anybody who's not familiar. Basically what I'm talking about is it's a replacement for shocks, right? Basically was what it is. So you're either going to have shocks or struts, shocks, or airbags on that vehicle, okay, which are all pretty much a variation of pretty much the same type of equipment, okay? So what happens is when it goes into place, you have to use something like this, and it's called the strut tool. Before they started making these strut tools, what would happen is people try to make makeshift equipment, and what happened is they'd compress this spring in order to try to squeeze it in there. Well, if they lost their grip or if it broke whatever they were using, basically what would happen is it would wind up having a lot of injuries, face injuries, hand pinches. Okay, so this strut assembly tool became a really, really vital part of getting vehicles fixed. So to the point to where I don't even know, I can't tell you the last time somebody I remember hearing somebody fixing a vehicle without a strut tool. Look how inexpensive they are these days. I mean, when these things first came out, they came out. What would you say, Jason and Carlos? Probably a couple $100 when they first came out, about 15, 20 years ago. Sue, anybody? I remember they were really expensive at the beginning. Yeah, I remember they were really expensive at the beginning. And now, just like anything else, right? They become very competitive, and the price gets significantly reduced. But we're talking about they easily paid themselves off in the savings of time, not damaging the vehicle, not damaging the wheel well of the vehicle, not harming the employee. Okay, so many different reasons why that tool was so. There you go, right there. Why that tool was so beneficial. Okay. Okay. So that's what I'm talking about. Different items like that. Okay. So it could be, like I said, stored energy. It could be a strut. It could be a capacitor. For electrical, it could be, like I said, it could be airbags. It could be a jack. It could be a come along. Okay. So anybody, let me see. Okay, and something like this, folks, it could be a come along as well. Okay, if they got it tightened up, it's under tension, and then it's got stored energy in it. Okay, so they're either that or a jack. One pulls, a come along pulls, the jack pushes. Okay. Okay, so in addition to that, also tool hazard recognition techniques. What are we talking about, right? That some classic techniques in order to recognize hazards, it might be like a job safety analysis, or task safety analysis, safety inspections, pre-job checklists, recognizing accident types and energy, and job observations. Do you see out of that list? Do y'all notice that about five of those seven or five of those six are basically the ones that we talked about in the evaluation? I'm sorry, that we talked about doing the evaluations. Okay, those 15 evaluations that we're doing for the end of the course. Okay, so if you look, I'm moving on to the right hand side. So let's talk about a little bit about JSAs, right? JSA, what are we talking about? Job safety analysis, right? Also, and this is the thing, and I'm going to tell you, and you've heard me say this before. NCCER, I think, has got a great product, but there are a few definitions in here that use that is no longer the case with OSHA. Okay, I don't agree with the incident versus accident, but if they're calling them accidents, we're going to call them accidents for NCCER purposes. Second of all, also JSA and JHA, we tend to use them interchangeably, but they're really not. The job hazard analysis, or the hazard analysis, is conducted by the employer. Employees usually do some type of safety analysis. There's nothing wrong with calling it the wrong name, as long as we don't push the responsibility of the employer to identify significant risk and control them before the employee even gets to work. And that's what I'm talking about. So that we can never pawn that responsibility, being the employer, off onto the employee. Okay. So regardless, we're just these words are kind of used to being interchangeably here, and we often do in the industry. So a job safety analysis, a job hazard analysis, right? JSA, JHA. And basically, what are we looking at? It's one approach to hazard recognition, right? And the task at hand, basically, what it's happening in the JHA is that the task at hand, it's broken down into individual parts or steps, and then each step is analyzed for its potential hazards, right? So that's basically the definition of a job hazard analysis, okay? Once the hazard is identified, and then certain actions or procedures or recommended practices that are either going to correct the hazard or minimize the hazard is what we're looking for. And then during that type of JSA, basically what we're doing is, let's say if we determine, I just showed you right here, the come along that I just pulled up right now. If we determine that a come along, right, we're using a come along to install a pump motor in a tight space would be safer than having a worker do it manually. And then by using a come along, the chance that the worker's hand is going to get caught or crushed during installation, it's going to obviously be significantly reduced, right? And we're going to reduce that by using an engineering control because we put this come along, this piece of equipment or tool in the place that you see on the screen right now. Okay. Also, JSA, right? It can also be used to as a pre-planning tool. It helps ensure that safety is planned into the job. And then also, whenever we use JSAs and we're pre-planning, and then we have to assure that we that certain information that we have certain information, right? We're gonna note or list any types of tools, materials, or equipment that we're gonna need or use. Staff and manpower requirements, basically the workforce that we're going to be using. We're gonna list the duration of the job, how long we think it should take, and then any quality concerns as well. Okay, and then in addition to a JSA, we can also wind up doing a TSA, right? A task safety analysis. And then basically, what are we talking about now? TSA or THA, task safety analysis, or task hazard analysis. And basically, they're really similar to the JSAs or JHAs, right? And then they're both requiring that the worker identify the potential hazards, okay, and the needed safeguards that are associated with doing that job, right? But the biggest difference is that it's used to report the difference is that the form is used to report the hazard, right? So the task safety analysis basically is going to be used to report the hazard, okay? And during any type of TSA, a lot of times will be pre-printed. Some of them will be pre-filled out. Some employers want you to fill them out by hand. And basically what we're going to have is a fill in the checklist, right? And basically that's going to be used to document any hazards found during the analysis. Basically, the employees are looking for additional hazards before we turn around and do that task, okay? So look, when you get to the questions at the end of this module, definitely you're going to probably be coming back to those two chapters, just so you know, okay? The 221 and 222, the job hazard analysis and the task safety analysis. It's probably going to bring you back to both of these. And I would definitely say that knowing the definition of both is probably going to be a really good test question as well. Okay, that first paragraph in each one, basically or I say first paragraph, first three sentences in each one, talking about what what the difference is. It'd be two really good test questions. Okay, and then in addition to that, also safety inspections, right? That they have to be done on a regular basis. And then, of course, depending on the size of the company, is going to determine how frequently they're done. Right? Are they going to be done? Are they going to be done daily, weekly, monthly, twice a year, or a few times a year on an annual basis? So basically, depending on the size of the company, depending on the types of hazards associated and the type of work, the nature of the work we do, will determine how often and how frequent we do any type of inspections. Okay. And then during the safety inspection, also tools, equipment in the work area, they're going to be checked for hazards, right? And it's important to make sure that we plan in advance what's going to be inspected. We have to have a work plan, regardless of what we do, including inspection. We should have a work plan. Might be a random inspection, but we should still have the inspection planned out. Okay, whether it's days, weeks, minutes ahead of time, but somewhat have a parameters of what we're going to be looking for. Okay. And then preparing for safety inspections. It helps ensure that the inspection's going to be done thoroughly and successful, right? It's also going to help promote folks' consistency. The biggest thing is I tell everybody, don't go out there and just start looking, right? If we have a checklist, even better, because that way employees can make sure that, if we have different personnel in safety, hopefully we're trying to be as consistent as we possibly can. Ultimately, it's to help protect the health and safety of the employee, but we also want to be fair and be consistent, okay? I think it helps them do their job better, and it also helps to improve the relationship between operations and safety. The following are certain questions, right, that we can consider whenever we're preparing for a safety inspection. Have there been any reported accidents, right, near misses, incidents, or anything? Who's responsible for inspecting each area? what tools, materials, and equipment need regular inspections. What did the last inspection reveal, right? What was the historical data of this group or this facility or this area? And then also, were the control actions adequate, right, and complete? Were they sufficient to ensure employee safety, right? Did we have many near misses? Did we have any injuries, recorded injuries or reported injuries, right? How frequently has the work area been inspected? And then who's going to correct any noted deficiencies? How and when? Basically, going back to your chain of command, and specifically on the operations end for any deficiencies that we find, right? And then any problem areas or potential areas can be dealt with faster or more efficiently whenever the inspections are approached, and obviously in this type of manner because it's more standardized, right? I tell everybody we're in the business of standards, folks, so we want to make sure that we stay standardized. Okay, so if you look at your next sheet, look at your safety analysis checklist. Okay, on 2.4, and then your safety inspection checklist for scaffolding on 2.5. Okay, this is two perfect examples, and this is pretty much how we're going to do most of the inspections, folks. It's going to be something like this, and it's going to be really similar to what we have in the book as well. It's going to be very similar to what we have in the book. Okay, so and then just basically going through like a task safety analysis, we're going to be going through any checklist, right? Like as far as underground utilities, have we located utilities where we're going to excavate in the areas where we're known to or suspected for unexploded ordinances, right? Like maybe are we working on an old military facility, right? Or perhaps are we working in an area that was previously, I'll give you an example. In New Orleans or in one of our suburbs, they found a training shell. It was something crazy like a 70 caliber or something. I mean, I don't know. There's something. It was a big gun. I can't even tell you what it was. Okay, but I mean, this sucker was huge, and it was an unexploded ordnance from. They said it was probably from the 1930s and 1940s, and a homeowner just recently found it. So of course they pulled in the hazmat team. The U.S. military came out. What it was about 60 years ago, 70 years ago. This used to be a training facility for the military. Okay, which is now a residential neighborhood, and they're thinking that that's what it's all wooded in areas now. It's very very suburban areas, so they a rural area, excuse me. So they think that it was an oversight, and it was just laying out there for many years, and just a little bit below grade level. Okay. And then also excavations, right? What kind of areas are the excavations adjacent to? Are they at least 5 foot deep? If they're at least 5 foot deep, now we need to start looking at protective systems, right? What do we need as far as what type of protective system to protect against cave-in? The methods that have been taken to control the accumulation of any type of water in this excavation. It goes on to right loose rocks, fallen material, any type of substantial stop logs or barricades that maybe have been put in place. Also, to prevent any type of public or workers, any equipment from falling in. So what kind of maybe, let's say, fall protective systems do we have in place, or barricading systems, maybe a better word for it, okay, to keep people away from the surface of the excavation. In addition to that, how many, let's see, all wells, calyx holes, pits, shafts, barricaded, covered, it goes on, right? Walkways. Do they have access to ladders within 25 feet? Excavations less than 20 feet. There's our slope ratio. Also, if it's greater than 20 feet, we're going to need a registered professional engineer. Okay, and it's going to go on, right? Tabulated data, basically talking about the weight versus the cut. And then if anybody's not familiar, I'm going to pull some stuff for you also on tabulated data, okay, for excavations. And then support systems all the way down to any shields that may have been put in place also, okay? So talking about finishing off protective systems. And then on the right-hand side, if you see there, we'll see a safety inspection checklist for scaffolding, okay? And I'm going to show y'all how to get to some advanced searches to find some really good audit checklists, but these are all basic, okay? So like I said, these right here, these two folks, actually the three with the JSA or JHA on the previous page, all three of those are examples of the documents that we're going to be using during the evaluation. Okay, and they're going to be really, really, really similar to what you see in there. So we're not trying to overly complicate it. We just want everybody to be comfortable with it. Now, I will tell you this. Depending on the employer, depending on the host site, many times they will be a little bit more complicated, what you see there. But I kind of see a trend now where employers and host facilities are really coming back down more to the basics in order to keep it more basic or more uniform in order to help protect employees. Okay. So I think we've gone away from complicated for the most part, and we're coming back to trying to simplify it. Okay. Um, okay. So pre-job, I'm at 2.24 now. And talking about pre-job planning, safety checklist, right? So before each job starts, we're going to do an assessment of the hazards, the risk that associated, right? Whatever safety needs we may have. And then we're going to do following pre-planning questions, right? To make sure that if there's any type of considerations that we need to make, and what are we looking at, right? Are there any special laws or regulations that are going to affect our job site? You know, is it a hazmat site? Is it a do we have to call 811? Okay, is it a historic area? Before we even start doing any work, there are going to be some EPA. There are going to be some EPA inspections done. They're called Phase 1 and Phase 2 inspections. Many of them, and what they are is they're looking for anything like I said, ordinances, military firearms, asbestos, lead. Okay, different hazards like that associated with the land. Okay, chemical release items like that. Okay, abandonment. Also, are there any hazardous processes, materials, or equipment, right, that are going to be on the site? What PPE or safety gear is needed for the job? Have workers been trained on any special tools or equipment that involve the job? Also, are there areas are all the necessary work permits in place? And then knowing the answers to the questions, we definitely know that they're going to help facilitate, right, writing a good accident and injury prevention program. Okay. And then also we're going to do things like observations, right? And basically think about this. Roughly 80%, I say 80, they say 85, roughly 85% of all accidents happen because of unsafe behaviors of workers. Do y'all remember, were y'all on the other day, or did y'all get to see the video link about unsafe behaviors and unsafe conditions? I talked about that unsafe condition can become a unsafe behavior, but an unsafe behavior will never become a unsafe condition. Do y'all remember that? I think I used the example of a AC unit leaking in the middle of the night or a water heater. Okay, so let me use it again just in case. Okay, let's say we are a construction company and we have our corporate office, right? And let's say that in that corporate office we have whatever, right? A hot water heater. Excuse me, a water heater. So we come in tomorrow morning at 6 a.m. and you're the first person that walks in, and the lights are dim, but the lights are on, right? And you walk in and you slip and you fall. And let's say the water heater was in whatever, right? 3-year water heater. There was no belief that it needed to fail. We bought a good quality water heater. We just had an issue, right? Could have been workmanship, may have not, might have just been an anomaly, right? Could have been a freeze the night before, might have busted a water line, whatever the case may be. Okay, so agree with me if you will. We walk in and the first person slips and falls, and they did everything they were supposed to, right? They turned on the lighting, they just missed it. Would you all mostly agree with me that that's probably a condition, an unsafe condition? Because the employee did what they were trying to do to be safe, and they still got injured. Would you agree with that? That it's still a unsafe condition? Okay. Okay. And then, so now let's take that same employee, right? And they walk in and the employee realizes that there's a leak, but the employee just goes on about their business, goes and starts making coffee, starts walking around, watching the news, getting on the internet at their desk, and don't advise anyone else. Don't block the walkway where there may be water ponding in the ground, right? And all of a sudden, the second employee comes in, and the second employee slips and falls. Now it's no that condition is no longer a condition. Now that condition is a behavior because the first person failed to warn and the first person failed to remediate or block off. Does that make sense? You see where I'm going with that? Hello? Okay, sorry. I just want to make sure I didn't lose anybody. I know y'all having problems out earlier. So what happens is the first one would have been a condition, right? The second one now, because the first person failed to, whether they were lazy, whether they just failed to advise, they failed to block off, whatever. That condition now became a behavior. Okay. All right. So that's a perfect example of how condition can become a behavior, right? But a behavior will always be a behavior because it may look like a condition at the time, but as soon as you realize that somebody ignored the safety practice, somebody didn't pay attention to it, somebody intentionally did what they wanted to do, it will always be a behavior. Okay. So let me fix this one more way. How many of you have heard over and over and over again people say, keep on talking about behavioral based safety programs, or people go back and start saying, well, it's a behavioral issue, it's a cultural issue, right? How many times do we hear that in the workplace? Yep. Well, and that's where I'm going, right? Is that the reason being is because it's normally a behavior that we don't correct or behavior of complacency, right? Conditions, like I said, conditions are only conditions for the first time, and then they turn into behaviors. Okay, but it could also been this. It could have been also that a plumber kit was called out, and instead of the plumber adequately fixing the water heater, right? They rigged it just to work a little bit better temporarily, and all of a sudden now we had a leak the next day. So that's another example is that it could be failure of project maintenance or failure of neglect of repairs or a business owner's reluctancy to fix issues. Those are all even though they look like conditions, they'll always be attributed to behaviors. Okay, so that's why it's almost always behavioral based. So now let me take it one more step, and then we're going to step out of this. Right? How many companies have you seen that preach behavioral based safety or are constantly looking at behavioral based safety programs? Mm-hmm. Yep. Okay. So now let's go one step past that. How many times have you ever heard an employer say, "We're buying a conditional based safety program"? You don't hear it, huh? It's in the behaviors. Okay, it's in the behaviors that we need to fix. So that's a perfect example of how that often comes into play. Okay. All right. So let's go ahead and move on, and then let's talk about hazard evaluation. Right. I'm at 3.30. And risk. What are we talking? We kind of talked about this in last week's. I was about to say episode. Excuse me. In last week's session, right? For anybody who wasn't on. And what are we looking at, right? Risk is basically measured in probability and consequences, right, of an event, right? How likely is it for something to happen, and then how bad is it going to be if it does happen? So a safe operation, right, is one that where there's an acceptable level of risk. So you're going to hear that often in safety is it's an acceptable level of risk. That means that, hey, somebody might get hurt, but we think we've minimized the risk so much, right? That we're controlling employees' actions, the level of training that they're getting, the equipment and materials, right? And that we've provided an area where work has to be done, but the risk of somebody being hurt now has become acceptable or tolerable. Okay. And then common ladder, right? It has some risk and that we have to consider. And then in order to properly to in order if the proper use of the ladder, right, is being used on a job and then it's erected safely and then it's in good condition, and then we're probably going to use it, right? So, but there's a level of risk there because knowing by accessing that ladder, or working off that ladder, there's always a greater risk that somebody's going to fall. Okay, so that's a perfect example. And then let's talk about evaluating the risk, right? So when you talk about evaluating the risk, we're talking about basically it's an important part of the evaluation process, right? To evaluate a hazard. Okay, we're going to categorize and prioritize it as well. So what are we looking at now? Hey, we might be talking about. Give you a perfect example how we do this on a regular basis. We often talk about. Let's see. Let me give you an example. Let's see. Give me 1 second. I lost my train of thought. I wanted to give you a good one. Okay, so maybe let's use guardrails. Perfect example, right? Let's say a scaffold, and we have a top rail and a mid rail. We still use fall protection a lot, right? So even though we've got top rails and mid rails, and that scaffold may be perfectly legally acceptable, right? That the front, even though the front may not have a guardrail system, but we're close enough, usually within 14 inches of the surface in front of us, it's got all guardrails on there, top rails, mid rails, toe boards, and there's not a significant risk of somebody falling, but we still require them to use fall protection, personal fall arrest. You see where I'm going? So what are we doing? So, even though it's an acceptable level of risk, maybe it's not to the acceptable level that we wanted. Okay. So determining the seriousness of the hazard, right, is going to depend on 3 categories: probability, consequences, and exposure. Okay. So a lot of times we talk about probability and consequences, but also we're going to throw some exposure in there too. So probability, what are we talking about, right? The chance given that the event's going to occur, right? So what are the chances that something's going to happen? What are the chances that Doug's going to fall off that scaffold, right? The results of the actions or the condition, right? Hey, if Doug falls, how bad can it really be, right? And then the exposure is how much time and degree on which somebody is exposed to a hazard. So, hey, okay, so let me start over, right? What are the chances Doug's going to fall from that ladder? Okay. Okay, it might be a 12% chance or a 2% chance that Doug falls from the ladder. How bad are the consequences they're going to be? Well, most of the time he's working over 12 feet, so they're going to be significantly bad, right? And then ultimately at the end, how often is Doug on that ladder? He's on that ladder day in and day out. Okay, he's constantly on that ladder. So that's a perfect example of where, all 3 would totally go ahead and increase our risk. Okay. And then the formula, right, works by assigning a numerical value of each category. And basically, this is what's going to happen, right? It could be something like this, like assigning values, let's say, like assigning a value of 1 to 4, let's say, where unlikely something's going to happen is a 1, possibly happen is a 2, probably is a 3, and then most likely is a 4. Okay. And then the same thing with assigning a value on the consequences, right? Negligible, right? Or not likely, right? 1, marginal, might happen. It might be a minor injury, illness. Injury or illness could be a 2. It's going to be more critical, a 3, and then catastrophic, a 4, right? So basically somebody can die or quadriplegic, let's say, okay? And then the last one is we're going to assign the value based on the exposure. How often are they on it, right? They're rarely on it. Doug's rarely on that ladder. Okay, he's on it a significant amount of time. Okay, he's on it a pretty good deal of time. Hey, he's always on it. Okay, so those are going to be the 4 that we're going to do. And then basically what we do is this. You take those numbers and we're just going to add them together, y'all. Look on your right-hand side. Look at figure 4. Okay, and that's going to be a scale. So we have 1 through 4, right? 1 through 4, 1 through 4. You can do this either 1 or 2 ways, y'all. You can basically turn around and say, okay, the highest value is going to be 12, right? And we're adding them together, right? We're adding the value of 1, 2, and 3, and we're coming out with our number. Okay, that's one way to do it. Some people also multiply it, so you can come out and saying, okay, we got a 2, right, times a 3, times if it falls, it can be significant, you know, and you got a 24, and I think the highest number there would wind up being 64, if I'm not mistaken. 32. It's going to be 4 times 4 times 4. Okay. Oh no, it was 64. Sorry about that. It was 64. Okay. So you see where I'm going with that. So, and if I decide to start adding them, my scale would be from 1 to 12. If I want to multiply them, which some people do, my scale will be from 0 to 12, or 0 to, or excuse me, from 3 to 12. If you're adding it, it could be as little from 1 to 64 if we're multiplying it. Does that make sense? And regardless, the lower the number, lower the number, the lower the risk, the higher the number, the higher the risk. But when we're talking about, like I said, risk, it's either one or two things, y'all. You're going to talk about probability and consequences, or probability, consequences, and exposure. Just depends on who you're talking to. Okay, insurance, we're probably talking all three. Okay. Now, I'm going to tell you, for y'all that are on the line tonight, I'm going to tell you the best thing is not a statement at this point, it's a question. Okay. If somebody turns around and starts talking about a risk formula, you know, this is what I want to know, right? I'll walk up to them and say, okay, so what are we talking about here? Correct me if I'm wrong, right? You're talking about basically probability, consequences, and exposure? Yeah. Okay, good. What number value system have you put on it? So let me give you an example, right? Those three that you just saw, y'all, some people will put numbers on them. 1, or 5, 10, 15, 20, right? 5, 10, 15, 20. So now what happens? Our low numbers are 15, right, on addition, and our high numbers are 60. You know, we do 1 through 4. Our low numbers are 3. Our high numbers are 12. You see where I'm going? It all depends, right? I've got a company that did it, and they put fractions on it, y'all. So their greatest risk was a 1.0. Everything else was a 0.2, 0.4, 0.6, 0.8, and 0.1. You know, whereas I'm like, man, don't do that. Just go 2, 4, 6, 8, 10, right? And instead of a 10, 100, you know, being the highest, right? 10 times 10, or 1,000, 10 times 10 times 10, their highest was a 1 if they multiplied it. Okay. It all depends on what the numbers are. It's the same stuff, y'all. It's the same stuff. It just depends on what your what multiplier you're putting on it, right? What denominators you're putting on it, and then whatever denominations you're putting on it is what you're going to go with. Okay. All right. So let's go to page 2.8. And then if you look at 2.8, right, let's talk about methods of hazard control. And hang on one second. Oh, I'm sorry. 4.0. I'm sorry, y'all. 4.0, identifying the cause. Okay. You see ITF, right? Immediate temporary control. You know, identifying the causes, right? Basically, we're looking at reasons why somebody would be injured or why somebody would be hurt, which a lot of times we know it. And what we can do is just put a little bit of science behind it now. And then go to the next page, and you'll see what I'm talking about. Look at the next page, and you'll see the tree, right? You'll see the root cause accidents. And this is what I was talking about, y'all. Look at the top. This is normally what we see, right? These are the hazards. You see what I'm saying? You know, look at the blossoms, right? And the blossoms are the injuries, right? The surface causes, right, of the accident or the incident. You'll see the conditions on one side. You'll see the behaviors on the right side, right? And then ultimately at the bottom, what do you see? Those are the root causes. Remember I said it's very limited as to the root causes? This is why I'm not a big fan of root cause analysis, because we try to pigeonhole it into 1 or 2. Okay? But there's anybody ever seen any of these before? Okay, good. Yeah, and it all depends, right? Anybody taken a root cause analysis class or anything in here before? Okay. Yeah. I've never taken the Taproot one. I've taken some other root cause analysis courses, and they're good. I mean, most of them are the same. I mean, you know, I've got somebody who came in here today and they're having some issues and they had a couple serious near misses to the point to where they're going to do root cause analysis. Okay. So like I said, it's definitely a good tool. I don't think we should always use the same tool for anything, right? There's no universal tool. Okay. All right. So there you go. Right. There's like I said, there's your root cause analysis of accidents, right? And like I said, anything from the injury illness itself to surface causes to the root causes. Okay. And then methods of controlling hazards, engineering, right? Reducing the hazard, safety devices, administrative controls, warning devices, PPE, and work rotation. I'm going to tell you me, I'll break them up into three, y'all. I always stick to that three. I always stay to engineering. Engineering could be substituting a less hazardous chemical or piece of equipment, right? Or eliminating the hazard altogether, or eliminate the process, which isn't always possible. And then I go to administrative, which could be worker rotation. It could be warning devices. It could be administrative controls themselves, right? Um, and then, of course, I'll also talk about, last of all, PPE, right? So, like I said, they've got different ones there, seven major methods of controlling hazards. I pretty much stick to the three. Okay. Is that what y'all do? Who sticks to the main three? Engineering, administrative, and PPE, and usually try to fit them into one of those three? Okay. All right. So, and what I'm gonna do is I'm gonna send y'all. Actually, what we'll do is in one of the next sessions, I'm gonna put up the hierarchy. I know we've done it a couple times already, but I'll put up, or maybe when we come back today, I'll put up the hierarchy of controls, and we'll kind of go through it as well. Okay. And going through exactly that. Okay. But like I said, I usually stick to engineering, administrative, and PPE. Okay. And then engineering and substitution. And the reason I call them the same is because engineering, basically substitution, elimination, in the old school were both components of engineering. Okay, folks, I'm gonna get us a break just so you know. It's 7:32. I'll get us a break in about the next 4 or 5 minutes. Okay. And then there's if you look at your right hand side, there's a root cause flow chart. I'll just kind of let you read through that this week, and then you'll kind of see where it's going. All right, you kind of just you kind of work your way through it, right? And you go from the injury and start determining what happened. Okay, so was there an unsafe condition? You start at the very top, and then you start working your way down. Okay, you're either going to go flow to the left or flow to the right until you get to an ultimate decision. Okay. Okay. Um, and then reducing the potential hazard. If you look at 5.2, hazards that can be controlled by reducing the potential for hazard, right? Easiest way to do this is things like this, right? That there's certain elements of potential hazard that we can reduce. Things that we can do is, first of all, distance, right? Hey, we want to keep employees safe for the road. Don't let them get on the road as much, right? You control by distance, right? Also quantity, right? Replace 120-ton storage tank with five 1-ton cylinders, right? So we can do quantity control or how we break bulk, right? Basically, is what we're doing. Also limiting personnel, right? Train small groups of 5 individuals instead of workers on site. So we may have to take more attention to detail and be more either more attention to detail and or more what's the word I'm looking for? Uh, More detailed training, and maybe that's the best way to explain it. Okay, and then safety devices, right? Barricades, power transmission guards. What are you talking about? Power transmission guards? We're talking about like guards over chain covers, right? Belts, sprockets, pulleys. Point of operation guards. Point of operation is any time where your tool meets the stock. So let me show you really quickly what I'm talking about. Okay, EHS911 machine guarding. Okay, that'll come up in just a second. Also, interlocking safety gates. What are we talking about? Gates to where if they're open, the machine will stop, right? The piece of equipment will turn will wind up stopping. Is a perfect example. Also, hand switches, any type of switches that are located outside the danger zone that have to be touched or held for employees to do the work. So I'll show you what I'm talking about on that one. So let's see. Why did this not open? Okay, here we go. Okay, so let me show you, for example, right here. Point of operation. Okay, so hand switches, it can be something like this, right? Both hands are out of the way, so there's no way that an employee's hand is in a point of operation. I'll show you what the point of operation is right here. It's where this laminate's being cut right there, where the blade hits the stock. That's the point of operation. Okay, where this press is bending there, that's the point of operation. Okay, where this die is hitting the piece of equipment that it's molding, there's your point of operation. Okay, and then where there's grinder, where you put your whatever you're grinding and it hits the grinder, there's your point of operation. So you get where I'm going, folks? It's wherever the tool, it's called wherever the tool meets the stock. Okay, and that's basically where your point of operation is going to be. Okay, okay. So let me go ahead and let's see, point of operation, hand switches, right? And then, of course, like we were talking about, right? Administrative controls, right? Easiest way to do it, control your people. Authorized personnel only, employee training. If there's ventilation duct, keep them on the upwind side of the ventilation duct. Let's say if they're doing a weld and you got a fan, extraction fan, never put the employee between the weld and the extraction fan. Put the employee on one side and the fan extracting on the other. So that way it draws the fumes or the vapors or the smoke away from the employee. Okay. And then, of course, warning devices, right? It could be bells, horns, whistles. It could be audio alarms, right? High noise, different types of warning devices like that. Of course, a PPE, work rotation, right? Rotating employees in and out as well for shifts, maybe help prevent against vibration. Could possibly be like prevent from vibration or something like that as well. Okay. And then that's it. And then you'll see that there's some terms there in the glossary terms. Okay. And then a few questions there. There's your 10 questions on page 211. Okay, starting 211 and 212. So let's do this, y'all. It is already 7:37. Let's take a break. How about we reconvene in 12 minutes at 7:50, and we'll run it for an hour. We're going to run one more module. Okay, I think we're doing good. I talked about this the other day for anybody who missed it. I think we're going to definitely be able to get through three is very small. You're going to see. We may even shoot for 4 tonight, but the thing is, I'm trying not to break up modules anymore, if at all possible. Okay, but I think we're going to be really close to it. As you see, this book, it's really cool because it does have a lot of filler pages, so I think we'll be good. All right, see y'all in 12 minutes, y'all, at 7:50. Thank you. All right, great, everybody. Okay, so this is where we're going now, right? Section 75-203. Excuse me, sorry. Right there, 203-1.1, okay? Page 3.1. I'll tell you that last one, the module 2, folks, that's one of the harder ones in here, and I'll tell you why. Everything they say is true and correct. However, in industry, people use that whole JHA, JSA, TSA, THA. It depends. Everybody pretty much has a different definition of how they use it, okay? What are y'all using for your hazard analysis forms, y'all? Let me know what you're using. JSA, TSA, JHA, JSA. JSEA, PHA, yeah, JSA, a couple of JSAs. Okay, and that's the way we should. Okay, JHA. Okay, yeah, we got different JSEA. I knew we had that too. Okay, and let me tell you what happens. Right, is JHA a lot of times a hazard analysis must be conducted by the employer. A job hazard analysis, basically, a competent person must do it. Right, and assessing the workplace for different particular hazards. However, what happens is we tend to use the terms interchangeably because employees never normally do a JSA. So whoever is doing it that way is really the better way to do it and the more correct way to do it. However, it's not really what the document's called. It's what its purpose is. And basically the employer, remember this, right, is that the employer has the first responsibility to identify all the hazards in the workplace. Okay. So the employer has the first responsibility because if they don't identify them and take those engineering, administrative, and PPE controls, or those list of seven controls that NCCER uses, or the new 5 with engineering, with substitution, elimination, and then engineering, administrative, and PPE, depending on how you want to look at it. Like I said, I use the most common 3. What happens is that's an employer's responsibility. Employees, we're supposed to identify, after the employer is identified, what hazards exist, what controls have been implemented, and then what we're going to do, especially if we find new hazards, right? So I tend to go with the JSA2. The only times it's different is dependent on certain oil and gas clients or pump facilities. Sometimes, or maritime, we'll also tend to use JSEA because they add the E in there for environmental, because we're concerned about material release, right? Especially in the water, of course, in the water and in the ground, right? So, okay. So let's roll on, folks. Let's go ahead and we're going to go ahead and kick it off now. We're at 75203 now, page 3.1. This is a very short. I think it's only like 5 pages. So I think we're going to go ahead and try to blaze through 4 as well. Okay, so I'm going to pick up the pace just a little bit, folks. Okay, so let's talk about it first, right? What are we talking about? We're talking about risk analysis and assessment. This is going to kind of piggyback on the whole probability consequences, okay, that we just did as well, okay? So probability, severity, and consequences. So let's talk about it from and I'm at 2.0.0, analyzing performance problems, right? What are we talking about, right? Certain concepts that we need to understand when we're analyzing performance problems. Things like a behavioral law of effect, observation and reinforcement, behavioral performance barriers, impairment factors, unpreventable employee misconduct, chances and risk, and then also loss of focus, right? So at a minimum, these are additional habits or additional performance problems that we're also going to have to keep tabs on, okay? All right, so what are we talking about, right? Look at 2.1.0, the behavioral law of effect. And basically what we're looking at is this, right? Behavior that brings reward is repeated, right? Whereas behavior that doesn't bring a reward or is punished is not repeated often, okay? So look at the, so what are we looking at, right? The law of behavior. It does not, however, say that the behavior is good or bad. It simply states that the behavior is rewarded. So a lot of times, I'll give you an example. Give me an example of shortcuts. Let's say if we do shortcuts, what's the reward that we get by shortcut? As long as nobody gets hurt, and we shortcut things in the workplace, what are benefits that we may get out of that? Yeah, save money. Absolutely, save money, save time. Right, I saw save time in there. Absolutely, right. Get out early. You know, absolutely right. So at a minimum, all that. Not only that, it's easy to do the lazy stuff. Right. It really is easy to just take the easy way out. Okay. So items like that obviously we have to reward good behavior, but a lot of times how do we reward good behavior? Well, and I'll tell you one of the ways, and correct me if I'm wrong, y'all, is safety bonuses. They did it for a while, right? The company would make X amount of dollars if they had 0 recordable incidents, okay, and say and finished on time, right? So they kind of added the safety component in there as well. The only problem with it is that at the same time when they did that, the it went ahead and encouraged lying on the OSHA 300 log, right? On incident reports, underreporting of issues. So different reasons like that, right? So, okay. So just perfect example, right? Okay, so observation and reinforcement, right? So what are we talking about? That observing a worker confirms and reinforces their behavior. Basically, a behavior-based observation maybe is the best way to explain it, right? Whether it's safe or at risk. And you notice there, look, and this is something that I've gotten really used to using these terms over the past 10 years, actually probably the past 8 to 10 years, is instead of calling things safe and unsafe, industry, right, especially a lot of insurance and oil and gas, it'll be called safe and at risk, and then it'll be safe and at risk behaviors, and then safe and at risk conditions, okay, as opposed to unsafe. Because when we kind of brand it unsafe, we're kind of branding it first of all, we don't want it to become realized, right? Once we've already branded it as that. And then I think a lot of it just becomes an issue of liability as well, verbiage and liability, okay? So at risk is pretty much a term that, I try to definitely get comfortable with that term, okay? And then it's because the workers being observed, right, assumes that their behavior is acceptable, and if it's done openly without any type of adverse consequences, they might keep on doing it. Okay. Another term I want you to get used to, and let me show it to you right here, is so if we're observing, that's why it's so important in safety that if we're observing an employee, we really need to know what they're doing and whether they're doing it safely or not, right? Whether they're at risk or doing it safely or not. Because what happens is, for any, I don't know how many, who's familiar with the term tacit approval? So if you're not familiar with it, check it out right here and read it right here. And basically, we infer and we imply, right, that we're given our approval. And there's a perfect example of it, okay? And that's a perfect example of what winds up happening. So what happens is we wind up, let me give you an example. In the last, let's say the last month, okay? Or let's say the last, whatever, month or 2 months that most of you have been on here now with these webinars. Let me give you an example. Can you relate back to anything in the last 6 months, year, 2 years that may have been a significant hazard that you just didn't see, that you just didn't catch? Can you relate to at least one or two that maybe you say, wow, with something I picked up, during some of these courses, I would have, I would have addressed it differently maybe, or maybe there was a significant risk. We kind of got lucky on that. Yes, no, maybe. Okay. All right. Perfect example, right? Okay. So most of you said, yeah. So let me give you an example. Would it is safe, or is it fair to agree that operations, production, and or line employees, right, whether supervision or line employees, that they probably got the assumption that it's okay to do it that way because we're there, we're watching it, and we didn't say anything? Do you think that'd be a fair assumption? Yeah, exactly. And what happens is, if you look at it, it's that whole the tacit approval can happen one of two ways, y'all. Okay. Sometimes it's with direct expression. I'll give you an example: the wink of an eye, the nod of a head. I'm not coming in on Sunday, so whatever needs to happen, y'all need to make sure it's done by Monday morning, right? Or hey, is safety coming in over the weekend? No, okay, well then we're going to do what we need to do, right? Tacit approval, whether it's on the safety side or supervisor side. But also, tacit approval sometimes can come from us not being aware of what we're really looking at. Okay, that's another example of it. Okay, all right. All right, good. So just to kind of give you an example, okay. Now I do tell people, I'll tell you what I feel though, right? Also is that there's only so much we can observe, y'all. We can't sit there and watch people work all day long, day in and day out. Let me ask you a question. How comfortable are you when you have a police officer ride behind you for miles and miles and miles and miles? What's the first assumption you get? That they're waiting until we do something wrong, right? To probably be pulled over? Do you think, or maybe here's a better question: do you feel much more unnatural driving, almost like you may potentially make more mistakes or a possible mistake just because of the person that's following you? And maybe not even now, maybe in the past, maybe when many of us were younger. Yep. So just keep that in mind, right? I tell people, I don't want to sit there. I want to observe your work. I want to talk to you. I want to find out what you're doing, right? Drop in, drop out, drop in, drop out. And sometimes you just have to stay. I understand that, right? Sometimes you just have to say. But what I wind up doing a lot of times is educate me. Tell me what you're doing. Hey, what's going to go on here? Explain how this works. You're rigging that rigging. Tell me why you would use that type of hitch, right? And things like that. And not necessarily quizzing them, but letting operations side know that, hey, I'm trying to get a better knowledge of it, because if there's a safer way to do it, let's talk about it, right? And if not, it's a better education for the safety professional. And the more they repeat it, the more they know it and the better they exercise it. The whole cone of learning, right? Okay. So let's talk about performance barriers, right? So, often we're talking about different types of performance barriers can affect our work and safety. And what are we talking about, right? We're talking about things like physical barriers, right? Knowledge barriers, execution barriers. So let's use a few examples, right? Let's talk about physical barriers, first of all. Physical barriers could be within us, normally within us ourselves, right? Or it could be in the environment as well. So perfect example could be, poor eyesight, right? Loss of hearing, or maybe somebody who doesn't hear well, or maybe even just putting ear protection in and now diminished hearing, right? Or just not being comfortable with it could be a physical barrier. Lack of individual strength or agility, right? A lack of individual intelligence or ability to retain. Okay, perfect example. All those are physical barriers. And then illnesses, right? Employees that may be sick, tired, fatigued, under the influence. All of those could be the physical barriers, right? It could also be another physical barrier. Perfect example could be the climate. Okay, it's if the environment's excessively cold, excessively hot. It could be a work barrier. It could also be an education and learning and training barrier as well. Okay, and then of course knowledge barriers, right? So knowledge barriers, what are we trying to talk about primarily? We're talking about, like, it could be education, either the lack of education, inability to properly read, could be dyslexia. Okay, all of those could be knowledge barriers. It could be training. Maybe an employee hasn't been trained enough. Maybe they haven't been trained adequately. Maybe they've only been trained once. Maybe when they were trained, they really didn't know what they were talking about, right, or understand the process. But now that they've worked for a few months, they'd better understand the process now. And when safety training, if we retrained, maybe they'd better understand what their responsibilities are, right? Also, the skill level of the employee. Is it a new employee? Is it a seasoned employee? And regardless of their tenure there, also, what's their skill level? Okay, the ability to understand written and oral instructions. Not everyone reads well. Not everyone tests well. Okay, and then of course language barriers, especially nowadays, right? We totally know language barriers. So we have, you could have people speaking limited English, English only, Spanish only, Asian, Texan, right? Whatever the case may be, right? So, but it could be any of the different language barriers, right? Okay, and then it could be an execution barrier as well. What are we talking about when we're talking about execution barrier, right? It's when a worker is physically or mentally capable of completing the task, but they don't do it. Okay, it could be it's mostly behavioral, right? And it could be a result of either a task barrier or an incentive barrier. Maybe they're not making enough money. Maybe they're not committed enough to the job. Maybe they want the job to go longer, right? Maybe the incentive they've been incentivized too much. Maybe they haven't been incentivized enough at all. Okay, just all perfect examples, right? So, and then of course, things like, what else, right? So we have performance barriers, and then we have impairment factors. Okay, distracted driving, right? Confused. It could be equilibrium issues. It could be somebody who's on drugs, alcohol, little sleep. Okay, like we said, texting and driving. It could be any of those. It could be a physical impairment. Just depending. Okay, so especially if those employees are operating any type of motorized equipment, right, or mechanical equipment, even more so, right? So we definitely even more so have to be more cautious of it. Okay, so that's just an example of a few. Okay, and then unpreventable employee misconduct. At 2.5.0, unpreventable employee misconduct. Right. Bottom line, they have a disregard for the rules, the procedures, the regulations. They don't care, or they don't know the rules, or they just violate them. Okay. And then chances and risk. Some people, they're just willing to accept a higher level of risk. Let me give you an example. We had this discussion today. Somebody who maybe plays with snakes, right? Somebody who plays with electricity. Some people are willing to accept a greater risk than others. Okay, so a perfect example, right? Jumping out, walking in front of traffic, or moving vehicles. Just different. We have, I think, a good way to put it is we have different. We take different chances of risk, but a lot of times it's also the different type of tolerances that we have as well. Okay, so then personal risk acceptance, right? Kind of like what we're going into right now. We're talking about. So what happens is it depends, right? And usually they're categorized by two factors, right? Of personal acceptance. The first one is it's not going to happen to me, and perfect example of that is people. It could be, oh, it's not going to happen to me, or it may be you think it's not going to happen to you, or maybe you just don't think it's going to happen to you, so you didn't really even think about it. It's just subconscious. So sometimes it's a conscious decision, right? Sometimes it's a subconscious decision, and then real versus perceived risk. Real risk. You might fall right now. Perceived risk. Like, hey, you may fall one day, right? You may fall, so you want to be cautious. So it's whether the person believes that it is a significant risk or not, or is it more of a philosophy of risk? Maybe that's the best way I can put it. And then let's see. Excuse me 1 second. And then voluntary and mandatory exposure. Right? It could be hazards we accept voluntarily. It can include like things like motorcycling, snowmobiling, jet skiing, right? Or it could be things that are involuntary as well, right? That may be items that we don't particularly have control over. Exposed leading edges, right? It could be where it's mandatory. We have to be there. Okay, getting on a plane, you don't have a choice. You have to be in the air if you're going to be on the plane. Okay, if that's how you have to travel. Being familiar with hazards, right, and considered to be lower risk. Certain hazards, right? For example, when you first learned to drive, how much cautious were we, and how much slower did we normally drive when we first learned how to drive? Some of us, at least, right? How much more cautious were we? Same thing with guns, right? How many people, at the beginning, some people are reckless. Other people are really cautious, and then we get a little bit more complacent, right? And that's where it's going, right? Is a lot of that familiar with the hazards is a lot of times it's that whole complacency. We get a little more used to it, right? Texting and driving, just being a little bit more cautious, being able to take a little, willing to take a few more chances, jumping out into traffic. Perfect example, right? And then controllable and uncontrollable hazards as well. Some we might be able to control some of the hazards in our environment. Other ones we're not always, not so much. So just depending, right? Risk compensation. When people are provided with personal protective equipment, right, or safety devices, we often become careless. So it's like I tell people, anybody out there who trains your people, or who issues PPE to your people? Okay, so I give you a perfect example. Anytime I do PPE training, right, or hazmat, have employees put on like Chemtech suits, right, Tyvek suits, whatever the case is, respirators sometimes, and hard hat, glasses, and welding equipment. And one of the first things I ask people is, "Hey, do you feel safe?" And if that person says, "Yeah," "No," that's good. That's the answer I want. You shouldn't feel safe. We shouldn't take it complacent, right? We should feel a little safer because we're a little bit better protected. But ultimately, y'all, if the risk didn't exist, we probably wouldn't have to wear it. Okay. So the only reason we're wearing that protective equipment is because we haven't been able to engineer out and administrate out all the hazards. So significant hazards still exist. And therefore we have to be protected before we go out there. Okay. So just remember that, right? And then also, sometimes no one's watching, right? Some workers only follow the rules when they're being watched. Okay. Other times, like I said, right, what happens on Sunday or at night, a lot of times when there's a challenge part of the job, when's it get done? At night on the weekends, right? So, it's one of those things where it's the difference between ethics and justice, y'all. Justice, we often do it because the law says we have to do it, or because we don't want to get popped by the law, right? Whereas ethics, on the other hand, a lot of times we do it because it's the right thing to do, or because that's what we should be doing. Okay, peer pressure and social conformity, right? So are coworkers doing it right? Is it becoming acceptable to practice at risk unsafely? Okay, so just items that we have to keep in mind, right? Acceptable consequences. What do we accept? An injury, right? A smashed finger, is it an acceptable consequence? Let's say whatever, minor superficial injuries to the face or to the body, are they acceptable? Right? So everybody has a different level of acceptance. And then, of course, loss of focus, right? Distraction or loss of focus, coaching and counseling, right? So we know what certain causes are, right, of the performance problems. So what do we need to do? We need to know how to coach or counsel, right? Those who are placing themselves in other situations. A lot of times, coaching and counseling, they're important tools to help communicate with workers. Okay, the skill makes correcting risk behavior, right, a little bit easier. I tell people the easiest thing for me between coaching and counseling is conversation, y'all. And you know what? but I also fully understand that sometimes certain employees don't want to improve, and also certain employees or even supervisors don't want to improve, and they don't want the area to improve. And at that point, we have to make a decision: are those people the best people that are going to be in that environment, or maybe it's us? Maybe if we're too sensitive, or if we want too so much safety, maybe we're the ones that need to leave that area. Okay, not leave that area or leave that organization sometimes. Okay, so it's hard decisions like that, right? But for me, it becomes more about culture, and then dealing with at-risk behaviors, right? They affect everyone on the site, not just workers taking risks. But when we find somebody whose behavior is too risky, what are we going to do? Hey, we're going to stop the worker without startling him or her, right? We're just going to try to stop work, take the worker aside, speak to him or her, express our concern for safety, their safety as well, and of co-workers, right? Um, State what action or behavior was incorrect. Also explaining the action or the behavior was incorrect or at risk. Try to find out if there's any reason, right, or any barriers, uh, uh, or any type of impairment factors, and then ask the worker what the proper way to perform that job is. See if they know. Okay, maybe find out when the last time they trained was. Right, leave it on a positive note. But I tell people, I try to do all this, right, and if it doesn't work, I'll go talk to my supervisor, or I'll go talk to their supervisor. Okay. And take it from there. A lot of times I'll let it go up my chain. A lot of times I'll let it go up their chain. A lot of times it's both. Okay. And sometimes people, hopefully they want to change. Hopefully they maybe don't have enough direction. That's a little bit easier fix. But sometimes when employers are just reluctant or resistant, well, and then at that point we kind of really have to decide, who's the conversation going to be had with. Okay. All right, and then dealing with safe behavior, right? People want and need compliments, right? We all want to feel good, right? We all want to get that attaboy. So when we see a performance, somebody doing a job safely, we should give that positive feedback, right? I remember years ago, folks, it was more like, who stopped that job? Nobody, who gave them authorization to stop that job? And a lot of times it was almost like the scarlet letter for stopping the job of voicing our safety concerns. Now, I'd say in the last handful of years, it's the other way around. Hey, Bob, great job, right? Great picking up on that near miss. It's that energized power line really could have harmed somebody, right? Hey, great job picking up the three top rails missing on that scaffold, and we went to a yellow scaffold or whatever the case is. So, just items like that we want to keep in mind, right? Also, when you when you observe a worker performing a job safely, right? What do we want to do? Speak to the worker privately, right? Specifically state the correct behavior that we observe. We want to compliment it as well. I tell people a lot of times, sometimes it's privately. If the employee is challenged, we should always address it privately or with the supervisor or with our supervisor. If the employee is excelling, I like to give them a shout out sometimes. We all kind of like that shout out. I mean, not to the point where it's going to embarrass them either, right? But I mean, I want to give them a shout out in private and then maybe give them a shout out in public as well. Okay. And then the ABC model, right? ABC model. So what are we talking about? It's a tool that helps us understand human behavior, right? Its the main objective is to find the positive ways to change behavior through positive rewards. So what are we talking about, right? We're providing understanding about why people have a certain way and why they behave a certain way. And it helps determine the patterns of the consequences associated with the behavior. All right. So it's called the ABC model. It stands for the activator, right? The behavior, and then ultimately the consequence. So by understanding the ABC model, what are we looking at is that we're including the relationship between the activators, the behavior, right, and the behavior and the consequences, and then of course the consequences and the behavior. So it's just all reoccurring, right? We're constantly working our way through all of them, right? And then as far as an activator, it's a condition that prompts behavior, right? So for example, if the phone rings, we answer it, right? The ringing phone is considered the activator. So what happens? If the phone rings, we answer it, right? There's our behavior, and then what happens with the consequences depends what phone call we answered, right? Depends on what was addressed. Perfect example. Okay. And then sometimes the activators are clear, right? And other times they're not going to be so clear. So some examples of activators that are easy to point out, right, are incentive programs, policies, signs. Those are all easy to point out, right? And then sometimes they're not so easy to point out, right? So sometimes they're not so easy to point out, and it's difficult to find an immediate cause for at-risk behavior, right? If we find that the activator is not clear, you know, and an investigation has to be done, we have to use some of the following questions, maybe to determine what prompted that at-risk behavior. Is there a rule, a policy, a procedure, right, that addresses the behavior? Is the rule, policy, or procedure specific to that exact behavior, to that specific behavior? Is the rule, policy, or procedure known, understood, and is it accepted as valid by the employees and by management? And is the behavior activated by practice, right, habit, or our peer influence on the job requirements? So just all different reasons and different types of questions that we should be asking, right? And then behavior, right? We know it's part of the second of ABC, right? The activator, behavior, and then the consequences. So what are we talking about? Is in the context of the model, the behavior refers to the specific behavior response to that activator, right? And then of course the consequences, right? What's going to happen, once we act on that behavior, and then all ultimately examples is the reward pleasurable or positive, right? Is the reward certain? Is it soon? Is it sizable? Those are all questions, because all those questions are going to help push forward, hopefully, a good safety practice. Okay, and then you see summary questions there, y'all. Okay, so you got 10 summary questions and 203 as well. Okay, so that's chapter 3, folks. So let's do this. Give me one moment, all right, and then just give me about 30 seconds, and then we're going to crank it out to chapter 4. We're going to go to. Give me 1 second. I'll put it back up on the PowerPoint as well, so everybody sees it. Okay, this is where we're going, y'all. We're going to 204, 75, 204. Okay, just give me one moment. Okay, so we're 75, 204 page 4.1. Okay. And I think we're going to be okay on time, folks. We got about 25, 30 minutes, and we should be landing this bird right on time. Okay, so basically, what are we talking about, right? 4 causes that make up about 90% of the construction fatalities, and it's items that we've talked about for the majority of them already. So we're talking about falls, transportation accidents, contact with objects and equipment, and then exposure to harmful substances and toxic environments. Okay, so those are where NCCER has put most of the weight. OSHA, of course, like we all know, there's the OSHA Focus 4, right? And if you notice, this was more of the causes of death in 2001. So we're going to talk about NCCERs, but I also want you to know OSHA's Focus 4, right? So let me bring you to the OSHA Focus 4 page. Anybody who's not familiar with it, okay? Okay, so for anybody who's not familiar with it, here's the OSHA Focus 4 page. I just did a post on LinkedIn yesterday, today, and you might see it there as well. This is more recent data here. And in a construction site, these are the 4 greatest hazards in the work site, which are falls, caught in or under or between, also being struck by something, and then of course electrocution. Okay, so those are OSHA's Focus 4, and those have been pretty much the 4 greatest hazards for OSHA for at least the last 6 to 7 years, if not longer. Okay, especially in construction, folks. Okay. Okay, so but as you see, like I said, if you see NCCER, they're talking about falls, transportation accidents, which often could be considered struck bys, contact with objects and equipment could also be considered struck bys, and then harmful chemicals and toxic environments. We tend to find toxic chemicals more in general industry than we do in construction. Okay, but they're still in both. Okay. And then you see your pie chart at the bottom, and it goes down to and break down to the percentages. Okay. All right. So I'm at page 4.2. So in addition to deaths, right, and immediate injuries to workers, unsafe conditions and practices, they can also cause potential problems, right? They might include damage and destruction to materials and equipment, scheduling delays or shutdowns, future health problems of workers, also damage to the environment as well, right? That's just an example of some of the damages that it can cause or problems it can cause. In addition to that, certain things are going to affect financial well-being, right, of the company, and they can definitely determine whether the company is going to win a contract or not. So what are we talking about? Hey, what about our high cost of workers' comp, right? What about our EMR, basically, right? What about OSHA's fines, right? Being on the OSHA citation page, and then ultimately also legal actions as well. And then also the OSHA reportables and recordables, right? What is our OSHA 300 log? So I'd say the four biggest ones that often are being looked at are workers' comp, what's our EMR, right? Our experience modification rate, OSHA citations and fines, the OSHA 300 log, right? What's our recordable rate? And ultimately legal actions. Okay, so those are the four greatest ones that I would actually say, not just the three. So let me show you something really quickly, folks, just for anybody who's not familiar. So everybody's familiar with the OSHA log. Easiest thing to do is this, and we're gonna be doing a webinar. There's gonna be a free webinar in New Orleans on April 27th on this. It's the OSHA 300 booklet, and it's a 4-hour course by OSHA. It's part of a grant. We're doing it here on April 27th. And here you go. This is a 12-page booklet, folks. Just in case you want to read it, it's really good. All I did was this, OSHA 300 booklet, and it's the first PDF that comes up, okay? And then also, in addition to that, let me take you now to OSHA citations. And right here, establishment search page, this one right here. And then what I can come do here, folks, is that I can wind up putting in a company here. So let's say, boy, I hate to pick on a company. Let's just go with this. Let's just go with state. I'm going to do Louisiana since we're out of Louisiana. Okay, I'm going to do open cases only. And I'm going to do anything that opened. Start date was, let's say, October 1st through now. Let's say October 1st, 2015, right through today. Let's see, an establishment name. Oh, select an office area, excuse me. Office area, Baton Rouge. Okay. And with violations. Basically, I'm coming in. I can check specific for a company, folks, or I can just check geographical area. And here you go. And these are all OSHA citations. Okay. Here's the citation itself. Okay. Now it comes in and it talks about, it's telling me the business code for the company. Okay. It's telling me when the investigation was opened up and the name of the company as well, and the number of violations. Okay. So if anybody's not familiar with this, that's where you get a lot of that information, and then you'll be able to come in, bring it in, even all the way down to here. You see this number right here where it says standard? This basically tells me it's 1926.0501. I know that's a fall protection standard in construction, and that's what the company was cited on for $5,000. Okay, so that just gives you an example of it. Okay, so again, let me show you how to get there. Everybody. All I did was go to Google, and I did OSHA citations. Okay, and it's the one that came up with establishment search. Okay, so if you have any contractors, you need to check them out. You got any companies you're going to work for? Do you have any competitors? That's the best way you can go check out all the information that you need. Okay. Okay, good. So let's go ahead and move on. Okay. Okay, so we are now at 4.2 in the left-hand column. And then what's all this mean to us, right, and our coworkers? Well, it depends, right? We're obviously looking at it could be significant hazards or risks with the company, right? The viability of the company. And then either way, this is what we want to make sure, right, is that we're going to be performing certain safety tasks. We're going to be performing, if it's a company we're working for, We're going to be performing inspections, audits, observations. Who out there does inspections, audits, and observations already for your organization, or maybe the clients having you do them for them? Yeah, it tends to be a pretty cookie cutter, right? Are you doing just blank paper inspections, or are you actually doing like an audit checklist or inspection form? Both. Okay. Yeah, we got a few of those, right? So yeah, checklist. Okay. Sometimes it'll just be like a daily activity report, dependent. What I do like about a checklist is that it's consistent. Okay, and that's what I really like about it. Okay, so also, to do these tasks well, what do we need to do, right? In order to do these tasks well, that's what we got to do. We got to serve as a resource to the site personnel for safety and health, right? That means we got to know our product, y'all. We have to know our product. We have to know as much training as possible, right? We need to know as much about OSHA as we possibly can and employee health and safety, right? We also got to follow the rules, right? We got to review the company's past safety performance, including injuries and illnesses. We got to understand the hazards that are associated with the type of work that's being performed, right? And if we don't know, that's okay. You know, what I tell people a lot of times is I know safety. I may not know your process, but that's why I'm there, right? And that's why they're there to get me up to speed on their process so we can talk about maybe where the challenges are. Okay. In addition to that, we also want to learn the company's policies, procedures, and work practices as well as possible. We want to make intelligent decisions to develop solutions, right, in order to help eliminate hazards or unsafe work practices. And we also want to develop people skills so that we can talk to personnel on site, including workers, supervisors, and superintendents. I mean, communication is going to be extremely important, right? And then also, in addition to that, there's going to be certain reasons for conducting safety inspections, right? Audits or observations. We want to be able to identify and fix unsafe conditions or at-risk conditions, right, and practices before they wind up happening, right, or before they wind up harming somebody. So remember, we do want to follow the hazard control process, right? We want to identify any unsafe or at-risk conditions or practices or behaviors. If the condition or practice is in imminent danger to workers or property, we want to provide an immediate temporary solution. You know, normally immediate temporary solution for me is stop, redirect, and then let's kick it back off if we can, right? Determining the cause of say unsafe conditions or practices or at-risk conditions or practices. Following up to be sure that the corrective actions are really fixing the problem, make sure that they're being implemented. We also want to be able to document, right? We're going to document our audits, our assessments, or our discussions, and ultimately what corrective actions the employer or the group has taken, right? So, okay, good. And then safety inspections, right? We want to do safety inspections as well. We want to involve checking the work areas to identify and report any type of hazards that need to be corrected, right? Behavioral hazards, condition hazards as well. Okay, and then you see at the bottom, right? Why worry about safety? Hey, look at accidents and incidents, right? They increase insurance premiums. We lose equipment. We have delays in construction. It could be legal costs. It could cause shutdowns and fines, right? And then what happens? Hey, we might have to bid more money, right, to recover. Poor reputation. Our schedule runs over, so now we're on delays. Company wins fewer jobs and contracts in the end. We work less, we pay lower. We tend to do more of the crappier work. Okay, so I tell people it doesn't mean we're not going to work. It just means that we do poorer work for less money, right? So last week we were kind of light in here last week, and I definitely suggest y'all go back and look at it. Let's see, Jason, Carlos, did it help last week when we did the workers' comp dollars on the EMR formula in order to calculate how much more it costs a company when they take a couple injuries on the workers comp cost? Okay. Yeah, we're gonna clean. Like I said, we're gonna clean that sheet up too. Okay, that's not for test purposes or anything, but that's for y'all. We want y'all to have a good formula because when y'all have it, we have it. When we produce it and give it to y'all, we're gonna have it for ourselves as well. Okay, so yeah, we're gonna probably be working on that over the next week or two, like I said last week. So okay, good. And then if you look at the hazard control process, right, in the right hand side, look, y'all, this is the thing, right? It's cyclical. Okay, it's going to be a cyclical. It's going to be a cyclical process, and you jump into it wherever you want, right? Let's say let's jump at the top, right? Performance safety program. We got to have that safety program in place, right? We got to identify hazards, right? Unsafe acts, conditions. Provide a temporary solution if necessary. Determine how or why the hazard is maybe unsafe or needs to be addressed. Determine solutions, right? Implement the solutions, and then we follow up. And then we keep on going. It's just cyclical, right? We just keep on working it over and over again. But look at the documentation in the middle. At every step along the way, we should be documenting. Okay. What does OSHA say if documents don't exist? We probably didn't do the work, right? So just keep that in mind, okay? So yeah, so safety inspections, that's why it's so important, because we have to hit all those milestones away or on the way, and we just continuously hit them, okay? So what kind of inspections are we talking about? Well, it depends, right? They might be periodic, they might be intermittent, they might be general inspections. Hey, we might have that daily, weekly, right? Monthly. It might be intermittent, might be, hey, you know what? It's Tuesday. We haven't had a random in a while. Let's just do a random. It also maybe all of a sudden now, maybe we had two back pulls. So we say, hey, let's go look for ergonomics on this one, right? If we see any other significant risk, we'll address it. But we're primarily looking for ergonomic practices, right? Safe and at-risk ergonomic practices. And then it could be general inspection too, right? Just an overall, just general inspection, just kind of just a look-see and see what's going on. And could be formal or informal inspection, right? So items included in inspection, right? Things that we may, some things that we may need to include, environmental factors like lighting and ventilation, making sure, right, that we have adequate lighting, adequate ventilation for the employees. Hazardous supplies and materials, production and related equipment, power source equipment, electrical equipment, hand and power tools, personal protective equipment, first aid supplies and equipment, fire protection, walking and working roadways, surfaces, elevators, stairways, man lifts. These are all different things we're going to check out, right? Walking surfaces, transportation equipment, warning and signal devices, right? Also make sure that we have safe and adequately rated containers, like chemical containers, perfect example, right? Storage facilities, structural openings like doorways and windows. We want to make sure they're in good repair. Buildings and structures in good repair, the grounds and storage areas, loading and shipping platforms, making sure that they're adequate and safe. And then down below, you'll also see a list of lockout tagout procedures, right? And there's a lockout tagout checklist, for example. So what do we want to make sure? That all equipment, right, machinery is compatible of movement required to be de-energized, right? Is it possible to be de-energized? Where the power disconnecting means for equipment does not also disconnect the electrical control circuit, right? So sometimes it'll be from electricity, sometimes it'll be a different source. Also, are the appropriate electrical enclosures identified? Is it high voltage, right? How many volts is it? Is it AC? Is it DC? Okay. Are means provided to assure that the control circuit can be disconnected and locked out? Is it capable of being locked out? Some equipment in the past could be de-energized but couldn't be locked out, and still in existence, right? Is the locking out or control circuit in lieu of locking out the main power disconnects? Okay, so are we going to a circuit board or something, or a disconnect? Okay, are all equipment control valve handles provided with the means for locking out as well? And I'll show you some pictures of these when we come back next week. I'll show you some pictures of them as well. Does the lockout procedure require that stored energy, like mechanical, hydraulic, air, etc.? Do we have to release or block the equipment while we're in lockout tagout state? Are we going to be bleeding off the line and leaving the reservoir open? These are all questions that we're asking, right? Appropriate employees provided with individual keyed personal locks. Make sure that each employee has their own personal locks. Unless we're in some type of group lockout tagout, and then we want to make sure that we're doing a due diligence list as well in all cases. Also, is it required that only the employee exposed to the hazard place or remove the safety lock, right? Sometimes, like I said, usually it's group lockout tagout, especially in energy services. Our employees instructed to always push the control circuit button stop immediately after checking to see if it's locked out. We talked about this last week, right? And like before, always try to make your lockout tagout equipment fail. When you apply it, always try to make it fail. Okay? Try to make it start up, try to make it stop, because I stepped the line before that, right? So attempt to start it up, see if it starts. Try to hit the certain control buttons, see if you can try to make it start. Try to push on breakers, whatever the case may be. Is there a means? Excuse me, I'm sorry. Is there a means provided to identify all employees who are working on lockout, tagout equipment? Yes. Easiest way to do that is a log, folks. Okay, just maintain a log. Maintain a JSA as well. Okay, have fail-safe documentation. Have multiple documents, right? So you can cross-reference. Is there a means provided to identify any and all employees who are working on locked out equipment? Okay, by either the locks or the tags, right? By group. Is there sufficient number of accident prevention signs or tags, basically telling us, hey, do not energize, right? We're in the lockout tagout process. When machine operations, configuration, or size equipment operators have to leave their controls, right? Are we going to be able to station to install tools or perform other operations, or when they're going to be part of the machine's going to be activated or moved? Is anybody possible to be able to accidentally start it, right? Or does it require separately locked or blocked out equipment? Okay, and then ultimately, in the event that equipment or lines cannot be shut down, locked out, or tagged out, is a safe job procedure established? Okay, originally known. OSHA says that we can either lock or tag in construction or general industry, right? But OSHA also says that our if we go to the tag process as opposed to the lock process, that we must be able to demonstrate that our tag process is equally as strong as our lock process. Okay, so let me tell you, and you've heard me say this already, right? Let me go to lockout tagout on here. Okay, so we're talking about locks and tags. All right, those tags right there have to be able to sustain 50 pounds of tug force, right? So we may not have a lock. We may just tag it out, and it's perfectly acceptable just to tag it out. Is it as safe? Depends, right? It really depends on, I guess, what the work practices are at the facility, I think. I tell you what I say is I always prefer a lock, but I also understand sometimes that it's going to have to be tagged out. And OSHA says that we must show that our tag process is equally as strong as our lock process. The only way I can tell you folks that I can do that and I can assure that is that I'm going to have to take the same disciplinary process, right? The same disciplinary practice with employees. I'm going to have to discipline an employee who pulls a tag because it's a 50-pound tag weight, tensile weight. I'm going to have to treat that employee just as if they would have grabbed a pair of bolt cutters or a hacksaw and cut off that lock. Whatever disciplinary action I would take for them defeating a lock is the same disciplinary action I think that I'm going to have to take for them defeating a tag. Anybody else have any other opinions on that? Okay. Yeah. If you have any thoughts on it, please, by all means. I mean, look, I know the physical barrier is always better, right? Always. But like I said, OSHA does leave us that leeway, at least in general industry and construction, that we can demonstrate that our program is equally is sound. Okay. Okay. And then safety inspection timeframes, right? Things that we're going to be looking for, right? Questions that we're going to be asking ourselves. How severe is the loss potential, right? What is the potential for loss injury? How fast does a part of or equipment wear out? Um, what is my site's past safety history, right? Does OSHA or another agency require inspections? So these are all items we want to talk about safety inspections, and especially how fast is a part going to wear out? Because the faster it wears out, obviously, the more at risk we're putting employees and putting them back into the machine. Okay, so just around that piece of equipment. So just keep that in mind. Um, So also safety inspection findings, right? We want to make sure that whatever we find an unsafe condition or an at-risk condition or behavior that we think presents an immediate danger. What are we going to do? We want it fixed right away, right? At a minimum, we want employees to stop work. Okay, so For our first actions, what we're probably going to do is it may be immediate and temporary, but enough to prevent a serious fall, right? So let's use an example. If the equipment is powered on, what are we going to do? Turn it off, right? Attach a danger or do not operate tag on the equipment. Set up safety cones to alert workers that the floor may be slippery. Arrange for the floor to be cleaned, right? So remember, as employees, as employers, and as representatives of the employer, we have a duty to warn, a duty to stop work, right? So there you go. That's a perfect way that we'd be, if we came up on a piece of equipment that was leaking oil under the floor, that's what we'd do, right? We'd go ahead, we'd turn off the equipment, we'd put up danger signs and do not operate signs. We'd set up, or we wouldn't turn it off. We'd have somebody turn it off that's qualified, right? Excuse me. Set up safety cones or tape or barricade the area, and then arrange for the floor to be cleaned, and the piece of equipment can be addressed by that time by supervision or management to determine how it's going to be repaired, right? And then safety audit timeframes, right? During an audit, right? We'll need to review applicable safety policies and standards. We need to make sure that they're up to date. We also need to make sure and determine whether the policies and procedures are accurate, right? So what are we going to do? What should we ask ourselves? Hey, is the policy or procedure, does it still apply to this work site? We don't want a cookie cutter, right? We want site specific. Is the procedure accurate? Do the policies and procedures address the hazards and the required safety precautions? Is the procedure being followed? These are all items that we want to know right offhand. Especially, I mean, ask yourself those about lockout, tagout. That's a perfect example. Machine guarding, right? Those fall hand in hand with what they still should be. Okay, so they're really those questions are, in my opinion, are very timeless. Okay. And then safety observations, right? 4.4. Folks, we're going to run for. I'll get you out of here probably in about 10 minutes. Okay, just so you know. So we're getting really close. Um, Safety observations, right? A safety observation is the act of watching that worker or group. We talked about it earlier, right? See how they do their job so we can identify safe and at-risk behaviors, right? When we perform that safety observation, we want to perform it, and we'll need to do the following, right? We want to observe the worker and the performance of his or her job, right? We want to validate training and job instructions. We got to kind of know what they're doing. So the best thing to do is read whatever their training was and job instructions were, and what their work orders are, right? JSAs, TSAs, and give us a better idea of the task being performed, right? Note safe and at-risk behaviors and note safe and at-risk conditions, and then provide immediate feedback to the worker or to the supervision, right? When necessary, especially if it's something that needs to be stopped, but even positive. I mean, I think we really want to go ahead and give that feedback as quickly as possible. And then safety observations time frame, right? We want to make sure that, same thing, right? The frequency of those safety observations. Are they daily, weekly? When are they? And then we need to stay alert, right? We also need to monitor the work areas, and then we have to follow some of the common. The following is a list of certain common unsafe acts, right? Failing to use our PPE, failing to warn coworkers when there's a possible hazard, not following instructions or procedures, right, or sound advice, using defective tools or equipment, or using the wrong tools or equipment, right? Improper tool for the improper job, also improper lifting. Um, Taking an improper work position, ergonomics, right? Making sure making safety devices inoperable, basically beating out the safety devices or the guards, operating equipment at improper speeds, basically normally too fast, right? Is usually what we're doing. Operating equipment without authority. Maybe we're not authorized or trained to work on that piece of equipment. Servicing, repairing, or adjusting the equipment while it's in motion or energized. Let me go back to the last one, right? Operating equipment without authority. That's why I went back to that machine that's leaking oil. Maybe it's not our job to stop it. Maybe it is. Maybe it's not. But we have to know what authorizations are, right, as well as the other employees. Loading or practice or placing equipment or supplies improperly or dangerously. Using equipment improperly. Working under a suspended load, right, that may be considered excessively dangerous. Working while we're under the influence of alcohol or drugs or horseplay, right, just to name a few. And then the following is a list of the most common noted unsafe conditions, right? Or at-risk conditions, congested workplaces. It could be congested with tools, equipment, or other employees, right? Defective tools, equipment, or supplies, excessive noise, fire and explosive hazards, hazardous gases or hazardous atmospheres, It could be oxygen deficient. It could be toxins. It could be explosives. It could be anything like gases, dust, fumes, vapors, right? Inadequate supports or guards, inadequate warning systems, poor housekeeping. It could be poor illumination or poor ventilation, right? It could be any of those, right? And then also safety observations and findings as well. When we see workers performing an unsafe act or practice that presents an immediate risk, accident, we may have to call a stop work if we have that authority, right? If not, we may have to recommend. But the biggest thing is keep this in mind. Things that we want to do, we want to keep our cool, right? We definitely want to keep our cool. We definitely want to keep our cool. We want to try to stay as calm as possible. We don't want to really startle anybody. We want to tell the worker that we're concerned for their well-being or the work environment's well-being, everybody in the work environment. State the nature of the unsafe act or practice or at risk, right? I mean, they started off with the right word and then it kind of went to unsafe after a while. Inform the worker of the appropriate safety rule or practices or procedures. We need to explain the following safety rules. I think a lot of that also, maybe stand down or additional training if necessary. Demonstrate the correct procedure if necessary. If we know the correct procedure, it may not be our place. It may be operation side. Okay. So we just have to remember that we need to know our limitations as well, right? Let the worker practice the procedure with the guidance, and then close on a positive note. Now, look, they may not be doing it underneath our guidance, y'all. It may be doing it underneath the guidance of their supervisor, right? So, like I said, I can't express enough that we need to know our limitations as well as safety. Okay. I think for a very long time, as safety professionals, we kind of thought we had to guide people by the hand, and we're not. We're there in more of a consultant role now. We're there now as a kind of we're not really in a chain of command. We're kind of off to the side, and we kind of have to know our place, okay? Okay, so we're going to go ahead and close out with this last page, right? And then of course, our government regulations, right? As much as possible, OSHA regulations, EPA, DOT, NIOSH, or CDC. I will tell you this. As y'all have noticed, a lot of stuff we've talked about, sometimes it's urban legend, sometimes it's true, right? If you're going to say it's a standard, let's try to make sure we know it's a standard, okay? It's one of those things that it sometimes, but at the same time, don't be afraid. If it's a best practice, and especially if it's a corporate best practice for that site, for that facility, or that employer, that's okay too. It doesn't have to be a law. If you work for Monsanto, or if you work at DuPont, right? If you work at Shell or BP or whatever the case is, or you work for Turner, or you work for a Team or any of these other brand servicing companies, if it's the corporate policy, it's the corporate policy. There's nothing we can do about it. So just keep that in mind, okay? We don't always have to know the government standard. We just have to know the best standard, the one that applies, okay? And then, of course, OSHA standards as well, right? The more you know about the OSHA 1926 standards and the 1910 standards, the better off we are. I got to tell you, folks, sometimes I just tell people, I don't know. I gotta look it up, okay? What we're not is memorizers. We should be working every day, I think, to be better subject matter experts for our organizations, because that's what they really need us for, especially a lot of the workforce. But at the same time, we can't just assume it, okay? Because if not, we start minimizing our own the own importance of our position. And if we don't know, or if we're wrong, I think sometimes we just got to take ownership for it too. Okay, and then OSHA inspections, right? You know, some exceptions that allow OSHA inspectors immediate access to the work site, right? Now, normally when OSHA wants to come out, they're going to come out. If you don't let them on, they're probably going to go get a court order and probably come back, especially if they think it's imminent danger, right? But these are reasons why OSHA most commonly going to come out. First of all, they're going to be responding to a death or a catastrophe. A catastrophe is the hospitalization, if you see there, of 3 or more people for the same incident, 3 or more from a scaffold fall, 3 or more from carbon monoxide poisoning. It's really not used as much anymore because employers no longer have to report catastrophes. Now they have to report the hospitalization of 1 or more within 24 hours. Okay, and that's like in chapter 15 or 16. We're going to be talking about that in here, just so you know. And we're going to use that 300 log that I showed you earlier today. We're going to be using that list. Okay. Also, it could be routine inspections as well. It could be verbal complaints or referrals from other agencies. It could be follow-up inspections. It could be, like I said, referrals from other law enforcement agencies, whether it's federal or state or local. Okay, and And if OSHA inspector shows up at our job site, hey, first and foremost, be polite. Receive them. Don't And you may not be the one authorized to give them access. So we may have to bring them to a holding area. We may have to bring them to administrative offices, right? The waiting room, wherever we would take any other employees to check in. That's where we would want to have them until we can make sure that we pair them with the right representative from the organization, whether it's safety director, plant manager, a superintendent, whatever the case is, whoever's going to participate in the investigation. Okay. There's no need for them to just walk through, but we do not want to deny them access, and we can only give them reasonable delay as well, just enough to get all of our people in check and get them ready. Okay. And then don't leave them standing in the rain, right? The hot sunshine, get them in, right? Get them somewhere comfortable. Like I said, and get with supervision and leadership as quickly as possible. Okay. Just let them know just stay in communication with them, let them know what you're doing. And by all means, folks, the book doesn't say this, do not start announcing to anybody that OSHA's there. It is $1,000 fine. I think it just went up to like $1,700 or $1,750 fine and up to 6 months in jail. Okay. And that's personal. That's not the company. That's on us if we start running around telling people that OSHA's there. It's called advance notice is what it is. Okay. And then, of course, show the inspector if they want to get water or offer them bottled water, whatever the case is. Okay. So, look, folks, that's it for module 9. Okay. You'll see that you got some more questions there on 4.9 and 4.10. And then when we come back, that's what we're going to do. When we come back, we're going to kick it off on employee motivation. Like I told y'all, tomorrow we're going to be recording these sessions tomorrow and probably early Thursday, just in case for any reason if we can't get on. We're gonna go ahead and run through them. And if you notice, you're going to notice that module 6 is a very long module. I don't know if we're going to make a module 6 in one night. Okay. So what I'm going to do, like I said, between tomorrow and Thursday and Friday, we're also going to be putting together all these evaluations and stuff for you. So we're going to, like I said, Thursday, next Tuesday, and next Thursday, it's going to be a little challenging to try to do the live session. So we're going to have a backup plan, and we're going to be sending out some material to everybody. That way, if anybody can't log on, or if we can't get you on, or if we can't get on here, excuse me, not me, because it's going to wind up being me. I want to make sure that nobody's hanging in the wind. I know when everybody's trying to test, and I want to make sure that we don't delay you in any way. If anything, that we try to send you some stuff to kind of pick up the speed a little bit. Okay. All right. Everybody good for the night? Anybody got any questions or anything? Okay, good. Okay. Hey, y'all have a great night. Thanks again. I'm sorry to push it all the way to 9, but I figured that way we'd close out those 3 modules. And I'm definitely happy about where we are. So it's we're doing good time on this. Okay. Thank y'all. Y'all have a great night, folks. Okay. Just reach out, call me, text me, email me if you have any questions. Okay. And I'll follow up with you tomorrow evening or Thursday morning about Thursday. Okay. Thank you.